Alright, let's look at the homework 6.3, problem number 2. Alright, so we want to use the shell method to find the volume of solid of revolution. And the region is bounded by this exponential function, x-axis, x equals 0, which is a y-axis, and x equals 1. Alright, so let's look at the picture first. Alright, so first one looks promising, but this is actually a disk method. And let's see, second one picture is not correct because it's going below. We have to be cut off by the x-axis. So fourth one is the same reason, it's not going to be it. So we have the winner here. Alright, so the third one is the correct picture. Alright, why don't we borrow this picture and try to set up the integral using a shell method. Alright, so here's the picture, and let's use the shell method. Alright, so as usual, so volume is going to go like, let's see, you start with 2 pi. Alright, so you have an integral. Alright, so the region to rotate would be, we are probably talking about, a region here. Alright, so in the first quadrant. So take with this region and then rotate it about the y-axis. Alright, so the region goes from 0 to 1 right there. Alright, so integral is going to go from 0 to 1, which is nice. Then we want to find the radius since it's a shell method. So radius of the cylindrical shell, and also we need to find out the expression for height. And then we are doing with respect to x, so you're going to have a dx first. So this gives us the thickness of the cylindrical shell. Alright, so take a random x, so probably right here. Alright, then radius is going to be, so you can see that they just the x-axis to x. So the radius is going to be simply x. Right? Then height. Height is determined by the function. Right? So this is going to be the height. So function is exponential function. So multiply by 7 e to the negative x squared. Alright. So let's evaluate this. So this is it for the integral. And I'm going to pull out the 7. So it's going to be 14 pi. And the integral from 0 to 1, x times e to the negative x squared dx. Alright, so let's do a substitution. I'm going to let u be negative x squared. So I would like to simplify this guy, so I'm going to call that guy just u. Right? Then you can take the derivative, so you would get the du over dx is equal to negative 2x. Right? And put this guy upside down just by taking a reciprocal. So you have a dx over du and 1 over negative 2x. Right? Then we can just simply multiply through by du to isolate the dx. So dx can be rewritten as du over negative 2x. Right? So, and also since this is a definite integral, we need to adjust the lower limit and the upper limit of integration. So x is originally goes from 0 to 1. So we have to turn that into a u value. Let's see, u value. So you just have to plug it into the substitution equation. So when x is 0, let's see, negative 0 squared is still 0. Right? When x is 1, negative 1 squared would be negative 1. Right? So we can rewrite this guy as 14 pi, just a constant multiple. And the integral actually goes from 0 to negative 1. And I'll leave x as it is for now. Then you have a e to the, we decided to call this guy u, right? dx is the equivalent to du over negative 2x. Right? So we can cancel x on top and x on the bottom, and also we can cancel 2 and 14, so that gives us 7. Right? And another thing we can do is we can incorporate this negative sign here, right, to switch the lower limit and upper limit. So you can actually go from negative 1 to 0 by incorporating this negative sign. Right? So once you clean it up, you just get 7 pi, and then you have an integral from negative 1 to 0, e to the u du. Right? This is a very simple integration, so 7 pi is just a number. Antiderivative of e to du with respect to u is just e to du again, our favorite function, and that's a negative 1 to 0. Right? Then we plug in, so 7 pi, then you plug in 0, e to the 0 is 1, minus plug in negative 1, so you have e to the negative 1. Alright, so this is the volume of the solid that we're interested in. Alright, so let's type it in. Alright, so we got the 7 pi and the parentheses. Alright, so we have 7 pi and what was it? 1 minus e to the negative 1. Alright, so let's check the answer. Alright, submit for testing. Alright, it came back and looks like we got the volume correctly and we have the picture correctly as well. Alright, that's it. I hope that this was clear.